All right, so today's video is focusing on sum and difference of cubes and squares. These are special factoring methods that we can use when we have very specific polynomials in front of us. Most of the time, we're going to see that they are binomials. So let's take a look at the formulas that we're going to need for today. So for our sum of cubes formula, it would look something like this when we would use it, when we have two terms that are being added and both of them are perfect cubes. So that means when we raise a number to the third power or multiply it by itself 3 times, that's what makes it a cube. And this breaks down to being a plus b times a squared minus ab plus b squared. Okay. And then we have difference of cubes, which is going to look very similar. 2 terms, perfect cubes, but there's subtraction in between. So it says a minus b, and then a squared plus ab plus b squared. Then we have sum of squares. So sum of squares is when we have a squared plus b squared, and that can be broken down to a plus bi and a minus bi. And then difference of squares, a squared minus b squared equals a plus b and a minus b. So in order for us to start each of these, we first have to decide if it's a cube or a square, because that'll tell us what formula we need and what way we're going to structure our factoring. So here I see that I have a cube and I have subtraction. So that means I want to use the difference of cubes equation. So I'm going to go ahead and write down the formula I'm going to use. I'm just copying that from above. For Algebra 2, you are going to get the cube formulas on the EOC, so difference and sum of cubes, but you do have to memorize the squares ones, but they're a little bit shorter, so hopefully that's okay. And then we have to figure out the cube root of each of these. So anytime we find the cube root, we write it like a square root, but this little 3 on the outside is what makes it a cube root. Okay, so the cube root of x to the third, the 3's cancel, and it's just x. And then the cube root of 64 is 4. So the x is going to represent our a in this equation, and 4 is going to represent our b. So I can take my a and b terms and plug them in to the equation. So I have x minus 4, x squared plus 4x plus 16. And there we go. So we're going to do the same thing with the next one. First, identifying what equation we need. Here I see a cube and a plus. So I need the sum of cubes equation. So I'm just going to copy it down from above so I know what I'm going for. And then again, I have to find my a and my b value. So I take the cube root of x to the third, which is x. That's going to represent my a. Cube root of 27 is 3. That's going to represent my b. And then I can plug in my new a and b value into this formula to find what the fully factored form is. So x plus 3, x squared minus 3x plus 3 squared, which is 9. Okay. So same thing in number 3. I see that I have a cube and a minus. So this is going to, again, be difference of cubes. So I'm going to write down my equation. Even though like the very obvious q is in the second position here, that's still not going to change how we solve. So I'm going to take the square root or the cube root of 1, which is just 1, and that's going to go everywhere we see an a. And then I'm going to do the cube root of a to the third, which is a, and that's going to be our b term. So everywhere I see an a in my equation, I'm going to put 1. Everywhere I see a b, I'm going to put an a. It's a little trippy. So I have 1 minus a. Oops. Let me switch my color again here so it's obvious. 1 minus a times 1 squared, which is just 1, plus a squared. Okay. And then moving on to number 4, here I see a square and I see a minus, so I want to use the difference of squares equation, which is, we're still going to follow the same pattern. I've just identified a different equation to use. So I have a minus b times a plus b. Now I'm going to identify the a and the b term. So square root of 9x squared is just 3x. Square root of 4 is 2. That 3x is going to be my a term. 2 is going to be my b term. So I have 3x minus 2 and 3x plus 2. Oh, forgot to switch my color. But same idea even when we're looking at squares. So a couple more examples here. This next one, I notice I have a square and a 2, so I'm going to do the sum of squares. So that's going to be a plus bi, a minus bi. I got to find my a and my b now. So take the square root of 16x squared, which is 4x. Square root of 25 is 5. So I have 4x plus 5i and 4x minus 5i. Okay. Now for 6, before I start, I do see that I have a square and a minus sign, so I want difference of squares. But I also see that there's a GCF here. There's a number that goes into both 3 and 27 that can make both of my numbers smaller. So for this one, the GCF is just 3. So if I divide each of these terms by 3, I put the 3 out front, and I get x squared minus 9. So when I do my difference of squares, I still want to keep that 3 in front, but I'm still going to have a minus b and a plus b. So to find my a and b, do square root of x squared, which is x, gonna be my a term, and square root of 9, which is 3, gonna be my b term. So I leave the 3 in front, because even though it's a GCF, it can't go away. I have x minus 3 and x plus 3. Lots of 3's going on in that one. All right, and then last one, number 7. Again, I see I have a 3 and a plus, so I want sum of cubes. And before I go ahead and start finding my a and my b, I can see there's another GCF here. I have a 2 that goes into both 2 and 16. So 2 comes out front, and I have u to the 3 plus 8. And sum of cubes, I have the 2 out front, but then I'm going to have a plus b times a squared minus ab plus b squared. So to find my terms, cube root of u to the 3rd power is just u. That's my a. And then cube root of 8 is 2. That's my b. So I keep that 2 out front, and then I have u plus 2, and u squared minus 2u plus 4. And there we go. That is a quick overview of sum and difference of cubes and sum and difference of squares.